Hello everyone. Today we are going to analyze this frame using flexibility matrix method. In this frame, the columns A, B and C, D having the same height as 4 meter. The beam BC has the length of 6 meter. In the columns there is no load. In the beam BC there is a concentrated load 78 kilonewton. It acts at a distance of 2 meter from B. In the points A and D there are hinged supports. In this frame the number of unknown reactions and moments are 4. There are 2 vertical reactions and 2 horizontal reactions. The available equilibrium equations are 3. So the degree of static indeterminacy will be 4 minus 3. So it will be 1. Let us release HD. You can see that I have released HD. To find the vertical reaction VA, let us take a moment about D. In this case, we have to follow right hand side rule. Clockwise will be positive and anti-clockwise will be negative. VA is acting in the clockwise direction so that it will be positive and the distance is 6. So 6 VA. This load is acting in the anti-clockwise direction so that it will be negative and the distance is 4. For VA, we will get 52 kilonewton. Then by applying this rule, we can find VD. By applying this rule, we can find HA, which will be 0. We know the equation which is used in the flexibility matrix method. Here P will be HD because that is the one we have released. In the point D, there is no horizontal yielding of the support. In this case, delta will be 0. We know that 0 matrix is a 0. Finally, we will get this equation. To find these two, we are going to use unit load method. We have to make sections. In this frame, there are 4 different parts: A, B, B, E, E, C, and C, D. So we have to make 4 sections: one in A, B, one in B, E, one in E, C, and one in C, D. You can see that I have made 4 sections. This section at a distance of x from A, this section at a distance of x from B, this section at a distance of x from C, and this section at a distance of x from D. Now let us make a table. In the table, first let us enter the members. There are 4 members: A, B, B, E, D, C, and C, E. For the section in AB, the origin is A. For the section in BE, the origin is B. For the section in DC, the origin is D. And for the section in CE, the origin is C. The limit for AB is 0 to 4. The limit for BE is 0 to 2. The limit for DC is 0 to 4. Limit for CE is 0 to 4. To find the moments in the sections AB and BE, we can use right hand side rule. Clockwise will be positive and anti-clockwise will be negative. Let us take AB. Up to this section, we have only the vertical reaction. It does not have any perpendicular distance, so the moment will be 0. Let us find the moment in BE. Up to this section, we have only the vertical reaction 52. It is acting in the clockwise direction so that it will be positive and the distance is x, so 52x. To find the moments in these 2 sections, we have to use left hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find M in DC. Up to this section, we have only this vertical reaction. For this, there is no perpendicular distance, so the moment will be 0. Let us find the moment in CE. Up to this section, we have only the vertical reaction 26. It is acting in the anti-clockwise direction, so that it will be positive and the distance is x, so it will be 26x. Now we need to remove all of the loads from the frame and we have to apply unit load in the direction of HD. By taking moment about D, we can find VA, which is 0. Then by applying this rule, we can find VD, which is also 0. By applying this rule, we can find HA. Let us find the moment M in AB. HA is acting in the clockwise direction, so that it will be positive and the distance is x. 1 into x, it will be x. Let us find M in BE. HA is acting in the clockwise direction, so that it will be positive and the distance is 4. 1 into 4, it will be 4. Now let us find the moment in DC. The unit load is acting in the anticlockwise direction, so that it will be positive and the distance is x. 1 into x, it will be x. Let us find the moment in CE. The unit load is acting in the anticlockwise direction, so that it will be positive and this distance is 4. 1 into 4, it will be 4. Using this formula, we can find delta L, and by using this formula, we can find delta. We have found delta L and delta. In this equation, let us apply both of them. For this matrix, we have to find the inverse. We have to write that upside down. We can take the members outside of the matrix. Then we can eliminate EI. For HD, we will get minus 9. We will get a negative value. That means the assumed direction is incorrect. We assumed that HD would be acting towards the right side, but actually it is acting towards the left side. Now let us take the original frame. We have found HD. It is acting towards the left side. In this frame, there is no horizontal load, so the values of HD and HA will be same, but the directions will be different. HD is acting towards the left side, so HA should be acting towards the right side. We know that the columns AB and CD having the same height 4 meter, so the vertical reactions which we calculated previously will remain same. Now we can draw the free body diagram. Using that, we can find the shear force values. These are the shear force values in the column AB. These are the shear force values in the beam BC. These are the shear force values in the column CD. This is the shear force diagram. Using the right hand side rule, we can find the moments at A, B and E. Then using the left hand side rule, we can find the moments at D and C. This is the bending moment diagram. Suppose if we draw the bending moment diagram in the opposite side, that is called the bending moment diagram on the tension side. This is the bending moment diagram by superposition method. Now we are going to end this session. Thank you for watching this video.